Hello, everyone. My name is Chris Overholt, and I work on the sales and solution engineering team at Algorithmia. And today I wanted to talk to you and walk through our workshop about how to operationalize your machine learning lifecycle. So just a bit about myself. Before I joined Algorithmia, I worked at Anaconda and RStudio on enterprise data science workflows and customers. So I'm very familiar with people trying to move Python and R models and other languages into production. And so in this talk and workshop, we're going to go through some of the challenges that a lot of our customers and users out in the world see, especially when they're trying to make their machine learning models useful to other organizations or customer-facing websites, things like that. So we'll talk about some of those challenges, and we'll talk about what the overview looks like first. So we'll walk through some challenges in machine learning deployment and really look at getting your return of investment on machine learning models that you're moving from development to production. And then we'll talk about how Algorithmia solves this particular problem in terms of deploying machine learning models, governing them, and operating them in a secure environment. And then we'll also talk a little bit about the data flow and the ML pipeline and where Algorithmia fits into your own kind of pipeline. And finally, we'll get hands-on with a lot of different workshop cases and use cases for things like deploying models, dealing with model pipelines, being able to call models from consuming applications, and then we'll wrap up from there. So most of the content will be in the workshop and example use cases. So hopefully, and we have a lot of documentation in our developer center for you to be able to try out some of these workflows on our public marketplace or our team site, during or after this workshop. So let's first start out and just talk about a high-level overview of what is Algorithmia and what problem are we solving. So Algorithmia is an ML operations and management platform, and there's a lot of challenges that we see out there as people are trying to move their models from training into production or deployment. You can see all of the different reasons that this cycle isn't as efficient as it could be. In fact, a couple of surveys out there, one by Accenture, one by us, shows that 85% of ML models really never make it past the proof of concept stage, right? So a lot of work goes into training and developing and model selection, but the ultimate last mile problem of getting the model out there is a very difficult one, and most projects don't pass that. The other thing we see is the time, right? On average, we see that it takes 18 months for models to go from development to production. And obviously, we want to shorten that down as short as possible to days or weeks, so you can have faster iteration cycles and get your models in use and in production. So these delays happen for a number of reasons. Things get stuck in the lab. You have different teams where stuff's getting thrown over the wall. You have technology mismatches of trying to deploy a Python model on different types of infrastructure, different versions of Python, different versions of dependencies, and finally, stakeholder buy-in and hidden technical depth. What that refers to is all of the infrastructure and all of the standard tooling that you need, version control, containerization, orchestration, to be able to serve a lot of models in a reusable way instead of having to build that pipeline every single time. So we really focus on three primary personas, right, or teams. And these three teams really come down to the first one are the data scientists that are actually building and testing models. So ultimately, we want them to be focused on, what tooling do they need, Python, scikit-learn, TensorFlow, and then we want to make it as easy as possible to take that model code and build and publish that so it can be used by others. Then in the middle, there's application developers. These are the people that are working on consuming these ML models. So this could be a customer-facing website or a dashboard, something that's being built in order to grab these predictions or grab these inferences that are coming from your ML models, or even just your Python and R functions, right? So we'll talk a little bit about that flexibility. And finally, there's the DevOps and infrastructure who wants to monitor this infrastructure and make sure all the models are healthy, make sure they're running, make sure they're low latency, so that they are up and running when you expect. So Algorithmia is an ML and operations and management platform, and we really cover three main areas. One is the deployment itself, so being able to connect your models to the right data, load in serialized models, serve as a model catalog, so you have all of your algorithms in one place, so you have a source of truth where things are actually callable, And ideally, you want this close to the point of business transaction as possible. And finally, this is where you want to validate models that they're ready for production. The second one is operations. So this is where we want to manage costs, control infrastructure usage, monitor operations, and even model performance. So this, has to do a lot with how much today do you have to manually, spin up instances or grow your cluster as more models or more demand comes, and how much can Algorithmia offload that from you having to manually manage that. So we'll talk about Algorithmia's auto-scaling functionality that really automates and abstracts away a lot of this manual work. Finally, and maybe the most important one, is governance and security. So deploying models is easy in terms of how we've abstracted it and made it a very clean process. Underneath all of these models, you could have 10 or hundreds or thousands of models deployed across your cluster. And governance and security means for every single model in the Algorithmia model catalog, you have things like role-based access control, secure API tokens, separation and isolation via organizations, and all of the calls across the cluster, all the API calls, are all logged in terms of who called what model, when they called it, and which data they were using. So it's very important in terms of compliance and governance of just knowing sort of the bubble around what is your model catalog, what's going on, so you don't have decentralized algorithms being served in all kinds of different places. So next up, let's talk a little bit about the workflow and kind of where Algorithmia fits in. So Algorithmia solves the ML production problem by dividing the world up into two workflows along the ML lifecycle. On the left side, you see the machine learning development side. Algorithmia is purposely not opinionated about what language you're using, what framework you're using. So we support 7 different languages, and whichever framework you want to bring along, these are some of the popular ones that our users are using. Basically, it means within Algorithmia, we don't prescribe how and what and where you train your models. So you could be training a scikit-learn model on your laptop, could be training an H2O model in a GPU cluster in the cloud, you could be using Jupyter Notebook, or you could be using an AutoML platform. So we believe very strongly that we don't want to limit what data scientists are using to develop and train models, because as soon as you do that, you're limiting the productivity and essentially the capability of your data science team. So on the development side, you sort of choose a model and go through the typical flow, which I'll show in a few minutes, of loading data, exploring the data set, training a model, and ultimately when you have a saved model and a trained model, this is when you go into Algorithmia. So Algorithmia works on the right side of this workflow, where we basically bring in your trained models and you say, I'm ready to move this towards production. And in that case, Algorithmia is going to handle the deployment, operations, governance, and security of the whole process, right? So we'll walk through that, but just keep in mind that there's training happening on the left side, and then there's production happening on the right side. And on the left side, we want divergence. We want a rich set of tooling. On the right side, we want convergence. We want a common path to production so that things can sort of behave in the same environment in the same way in terms of discoverability and actually calling all of these models. So hopefully you'll see that when we get to the hands-on portion. If you look at the bigger picture of the sort of the pipeline and data flow through Algorithmia, on the left side of Algorithmia, so Algorithmia basically fits in between things that you're doing in training, things that are happening upstream on the left, and then the consuming applications on the right. So on the left side, you might have ETL pipelines, you might have feature stores, and different training platforms or systems. And when those models are trained and serialized, they move into Algorithmia, which handles a number of things that we talked about earlier, some for data scientists, like the model catalog, versioning, pipelining, some for ops, like that deal with compute, orchestration, determining what runs on a CPU and GPU, things like that. And then on the right side, we have 14 different language clients that say, if you're going to consume these models with a batch job in Java, that's fine. Or you might be consuming them in a customer-facing web app in JavaScript or PHP, or you might have a dashboard in Python or R. All of those things are part of the right side, and those are essentially what's generating the demand for how we determine what models are running and how we're able to efficiently scale up and down around that. So think of Algorithmia as the place where you bring in your trained models, serve them in production, and then consume those, however that may be. If that's streaming, if it's batch, if it's real time, those are all supported because everything's happening over a REST API. So if you really look at the stages that someone's going through and they're moving to production, um, there's really 8 stages plus governance and security on the bottom. So as we walk through some of the use cases today and examples, just keep in mind, right, kind of where we're at in the flow here. So on the left side, we have things like, integrating with your training platform, whatever that may be, notebook-based, job-based, cloud, on-prem, whatever that is, connecting to your data sources. So we have a number of different data connectors to all 3 cloud vendors. And then, of course, you can connect to other types of data sources from an algorithm. Registering the model, making it part of the catalog, pipelining models together. So this is where you have 2 or more algorithms that are serving as a pipeline, and we'll show that in a few minutes, and how Algorithmia optimizes for this kind of runtime environment. Model management, meaning how do you manage different versions of a model? How do you tell, when you're going to publish a new version, how do we version that? How do we keep around old versions for continuity? And then on the right side is all about operations. So this is, model operations, infrastructure management, how are things scaling up and down automatically, and ultimately monitoring and reporting. And we'll talk about that today, both in terms of the cluster health and operations, like is the cluster healthy, are the models running, and also in terms of model performance. So not only are the models running, but are the models right, given real world data. So again, all of this is happening with governance and security at each step, and hopefully that'll become clear when we get into the hands-on portion. So let's do just that. And what we'll do now is walk through some real world examples and things. Again, you can follow along here. We have a lot of information in our developer center documentation, and I'll show you some resources that you can reach out to either during the workshop or afterwards, so you can get a good feeling for yourself for how this all works in Algorithmia. So what we'll do here, and I'll try to navigate through these and see how our time works out in the end. I may skip over 1 or 2. But what you can do here, if you have any questions about anything I've covered so far, feel free to post in the chat, and we'll get to it at the end during the Q&A. So this is kind of a good checkpoint if you have any high-level questions about where Algorithmia fits in, about maybe your own experience with deploying models. We'd love to hear that and talk about it in the Q&A. So with that, we'll proceed on to the hands-on portion, the workshop portion. And what I'd like to cover here are a few stories that we're going to walk through, right? So very first, we'll just cover platform concepts, like what is an algorithm, what is a model catalog, what is an organization, just so you have a good idea of the building blocks. And then what we'll actually do is kind of build a workflow where you start from scratch, deploy a first model, call an algorithm from an external application, and then if we have time, we'll talk about some of the automation that a lot of our users do in terms of automating, the build and publish step, or even adding in some approval workflows, right? Some kind of scans that check to make sure that things are as they should be, or reviewers that are getting requests and reviews to approve models. Maybe this is a risk management team or a model risk team. Once we cover those, we'll get into some of the latter topics, which are how do you build pipelines, how do you manage versions of models. These are all things that Algorithmia makes very easy, so that you get all the benefits of microservices, but without having to do all of the work of container networking and all the internals for that. Then we'll talk about usage reports and cluster health metrics and compliance auditing. This is a great place to think about if you're a data science team leader, if you're an infrastructure and operations leader. How do you get a big picture view of all of the usage across the cluster? What teams are using GPUs versus CPUs, or who's using the most compute? How healthy are things running? And ultimately, how can I look back at different compliance reports and tell, why a certain decision was made 3 months ago? So we'll talk about that. Finally, we'll round it out with one of our more recent features called Insights. And this is really all about flexible tooling to be able to monitor model performance metrics, right? So this is things like, these are things like data drift, concept drift, variations between versions. So for each one of these, I'll walk through some short steps and show an example. And of course, if you have any questions along the way, feel free to post in the chat, and we'll get to that in the Q&A session at the end. So I'm actually going to jump out before we get to the sentiment analysis pipeline. So let's walk through these different points in our platform, and I'll walk through in kind of chunks and pause along the way, just to make sure we're all on track. So let's start out, and so you're looking at, I'm logged into the Algorithmia platform. Our most of our users know this from our public marketplace. So if you go to algorithmia.com, you can sign up. It'll put you on a Teams account. You can look at our marketplace. Basically, this is a place where you can, bring and deploy your own Python models and really get a feel for what we do. And then most of our enterprise customers essentially have a cluster, an Algorithmia cluster deployed behind their firewall. Most of the time that ends up on their Amazon account or their Azure account, or we can even install on-prem. But basically what it means is we've taken our infrastructure, our stack that powers our marketplace, which has over 110,000 machine learning developers, and at any given time, there's more than 14,000 models running there. So we've taken that architecture and made it so that we can drop that in for a particular customer that wants to have their own model catalog behind their firewall. So that's what you're looking at. So I've logged into the demo cluster environment that we have as my user, and we're going to walk through a few basic concepts just to align you all with the pieces and parts that make the building blocks for how people use Algorithmia for their ML lifecycle. So let's start with the model catalog itself, right? So if I load up the model catalog, you'll see a number of different categories. These can all be customized depending on what types of models you're working on. But basically, it's a really easy way to say, show me all the computer vision algorithms, and I immediately see there's 5 algorithms. I can sort them, by most called or top rated. But this basically gives me an entry point to every model, no matter the language it's in. So we support 7 different languages: Python, R, Java, Scala, and some others. And basically, whatever language it's written in, model catalog means you can just go across and see all of the algorithms that you can either call directly or incorporate in your own model pipelines, right? Another thing to note, a very common question we get is, does this have to be a deep learning model or a sophisticated neural network? The answer is no, right? So when we dig into the code here and kind of see what makes up an algorithm, you'll see that this is all just Python code or R code. You can bring, you can pull any of the dependencies from any Python packages that you need, any R packages that you need. So a lot of our users, these models can range from a very simple utility function, maybe an OCR model or text parsing or processing model, to a regression model, something in scikit-learn or TensorFlow, or even a deep learning model with PyTorch or TensorFlow. So anything you can create in Python, R, Java, Scala can be set up as a algorithm or a function as a service platform kind of concept. So something to keep in mind as we go through the examples. So that's the model catalog. And again, it's a great way to discover what's on your Algorithmia cluster, what are things that you can call or add into your own pipelines. The second area here is data sources. So this is really important, mostly in the context of I've saved a trained model, I've serialized it like as a pickle file or a joblib file, and I need Algorithmia to see that so it can grab the trained model and serve it. This can also be used for bringing along test data, bringing along metrics from training, whatever you want to bring along from training and have close to the serving environment, you can use data sources for. So as data sources, there's a few different options. You can use a hosted data collection, which is just a kind of a file store that lives in Algorithmia itself. You can also connect to any one of Amazon S3, Google Cloud Storage, Azure Blob Storage. These are all native data connectors that we have. So you can go in and put your Amazon AWS credentials, put in your path restrictions, and whether this is a default connector. Basically, this means that I can define a connector once and then use Algorithmia's data APIs to access data in terms of reading and writing without having to post my credentials over and over, without having to repeat that. So it's a nice way to make a reusable connector. We also do a lot of caching and performance optimization with those native connectors. And if you're trying to connect to a data source that's not listed there, like a database or some other data lake, you can always do that. We have in our documentation, we have a number of guides for connecting to your data. So these are just some of the popular data sources our users connect to. So if you're trying to connect to Postgres or Snowflake, you can just follow the steps to do that, which would involve, say a native Python client within your algorithm. So that's data sources. And the last couple of things we're going to look at are organizations and API keys. So organizations are a way for you to group people, algorithms, and data as part of the same organization. So this kind of works both ways in terms of isolation and sharing. And by that, so let's go into one that we'll be looking at in a lot more detail today. Algorithmia SE organization has some algorithms. Some of them are private to this organization. Some of them are public, which means that anyone can access this cluster, can see them and use them. Members are people that are part of this organization. They're either developers or administrators. So administrators can publish algorithms across the cluster. And so you could imagine our customers use a lot of this for wanting to be able to group things in terms of teams that are working together or projects they're working on without having to have algorithms living within their user accounts. So it's great for collaboration, great for isolation. The last piece is API keys. This is a very fundamental part of Algorithmia because everything is REST API driven over secure HTTPS connection. This basically means that I can go in, create an API key, give it a name, and I can either give this full access to my algorithms or I can restrict it to a particular organization or a particular model. And from there, I can specify what level of data access it has through our APIs. This is on top of whatever access control you might have on your data storage systems. But this is a great way to generate a bunch of API keys. I might have, this is also a great way to exercise the principle of least privilege. So you might have one API key that's hooked into a customer-facing website that only can call one algorithm. You might have a different API key that's part of a CI job that's actually publishing new versions of an algorithm for continuous retraining. So that's what API keys are for. And you should know that the organization and API key concept goes very deep in our platform. So for example, if I'm on one organization and another person is in another organization, if we actually call the same model with different API keys, we're going to run those in separate containers so we don't have any leakage of the memory space between the two. So we're, again, built from the ground up to be multi-tenant secure, so you can trust this model catalog as a place to govern all of your algorithm activity. So that's the basic concepts. And let's see, next up, what I'd like to do is cover, now that you know the basics, this is a good point to dig into an algorithm and see what makes up an algorithm and how do I actually go from training to production. So let's do that. And the one we'll look at is, let's go in here and let's look at this credit card approval algorithm first. So let's first talk about what's here, and then we'll talk about how we got here and actually show the steps. So we're on an algorithm landing page. We're looking at a credit card approval algorithm. All of the stuff you see here is basically filled out. Whenever you create an algorithm, we give you a template. This is where you give it a name, description, tags, documentation, and then actually fill out the code, the calling function that we'll look at in a second. So here we see there's a name, description, tags. This is in Python. You're showing here the number of API calls this has received, call duration, and all the historical versions that we'll talk about later. But these versions are always available and immutable, but they're not always running and consuming compute resources and ultimately cost. So we'll talk about that auto scaling in a moment. On the right side, you see this feature importance plot. That's just coming from the documentation, which is just a markdown file, a README file in the repository. Each algorithm is backed by a Git repository. You can have that stored in Algorithmia's Git repo. You can have that stored in GitHub or GitHub Enterprise externally. But basically, within that repo, there's the README, there's the serving function, there's the dependencies, and anything else you want to bring along. So this documentation, the fact that we surface it here is a great place to fill out an overview of the model. What are the inputs and outputs? If you want to bring along any information from training, like this feature importance plot or F-scores or accuracy scores, this is a great place to do it. We can also show example queries, how this model was trained, a lot of that information as well. So that's the documentation and the metadata at the top here. And if you scroll about halfway down, there is a test console. So I can actually query this model and see how it behaves, right? So here are some sample inputs. And just to talk for a moment about this particular algorithm, this is using a data set that has credit card payment history. So whether certain people were on time or delayed with their credit card payments. And it's basically taking in customer information about whether they have a high balance, what's their housing situation, employment status, and it's taking that information against a test data set, or sorry, a training data set, and then returning whether or not my specific customer would be approved for a credit card and what their risk score would be, right? So if I hit run example, Algorithmia is actually querying this model, spinning up a container if it's not already running, and generating a prediction and returning that result. So this activity of querying a model is an important one, because this is what your external consuming apps are going to be doing, and essentially generating traffic against Algorithmia. Algorithmia is going to use that consumption or demand to figure out how much to scale up and scale down. And when I say scale up and down, that we scale container replicas up and down. We also can scale GPU and CPU workers up and down. So what we're trying to do is, across your whole model catalog, make sure that things are running performant, but also shrink the cluster down if the demand goes down. So if you have batch jobs that run at a certain time, we'll scale up, scale down. We're always trying to match the demand curve as closely as possible to save on costs, right? Then at the bottom, we're going to dig into this in a moment, but this is basically, I can take any of these 14 different language snippets, and we have native language clients for each one. So for example, with Python, we have an Algorithmia package, and at the bottom is this snippet. So I can take this code snippet, I can hand it off to a Python developer and say, if you call this code snippet, it's going to call an API, an algorithm in Algorithmia, and generate a prediction and give you back a result. And then you can build a dashboard around that, or whatever it may be. So this is a great place to, and we'll show some examples in a second. If you have a PHP website that's going to be customer facing or internal, and you want to generate predictions from Algorithmia, you could just copy this code snippet, hand it off to your web team, and they could implement that without having to worry about Docker, Kubernetes, Python, or any of the dependencies. They're just making an API call, right? So we're trying to have a very clean separation here of who's doing what. Or you might have an internal Java app, right? And you want to call a particular model, generate predictions, or process some data. You can think of it as kind of a central platform to do all of that. So we'll look at some consuming apps in a second. I just wanted to show that here in the context of an algorithm. There's a few other things here, like event listeners, right? So instead of making a REST API call, I can actually hook up an algorithm to an event listener, say Amazon SQS or Azure Service Bus, and I could have different things driving model runs, right? So for example, if I drop a number of documents in an S3 bucket, that could trigger an SQS message, which would come to Algorithmia and run a model, right? So there's different ways of consuming apps. Some are more real-time oriented, some are more streaming or batch oriented. We're very flexible about how you can call and interact with models. The last thing I'll mention here is the builds tab. And as we go through this workshop, you'll see us using some of this versioning and builds. Basically, because everything is version controlled, because everything is version controlled in terms of the code and the APIs, every time I save or do a git commit, that shows up as a git hash. And then only when I'm ready do I give that a version number. So you'll see that when we go on through later through the build and publish workflow. But anyway, the point here is that every time you make a change that's tracked, you can go back and call either your development commit and see how the model behaved then, or you can go back to an older version of the algorithm. Like I can go back from version 14 back to version 9 and see exactly how version 9 was behaving back then. They're always there, but not always running, right? It's something to keep in mind. Okay, so with that, let's get into some of the actual workflows here. So let's first look and see how this model came to be, right? Now that you know what makes up an algorithm. So I'm going to jump over to a Jupyter Notebook. This would be happening outside of Algorithmia. This could be a Jupyter Notebook or your favorite Python editor, whatever it may be, your favorite IDE. But basically, I want to show you, what would happen in training, and then where would I go from training to production in Algorithmia. So if we look at the algorithm we were just discussing, the credit card approval algorithm, I'll show you the code of how that was trained, where it came from, and most importantly, what we do at the end of this exploratory process to actually get it into Algorithmia. And I'll show you one specific way of doing that here, but there's many different ways to go about this process. So I won't read through this line by line, but basically, most of this notebook is traditional, data science exploratory work, training work. So here we're loading some packages like scikit-learn, we're loading some classifiers, we're loading in a Parquet file. Again, this could be coming from whatever data source you're using. Then we are splitting into training and test data sets. And then we're actually specifying the model. So we're going to load, instantiate a gradient boosting classifier, and then fit that model. Once we do that, you typically will do some kind of diagnostics and say, what's the model accuracy? Here's 80%. Let's do a few test predictions. So this is someone that has a good credit history, and they would come back as a low risk score and approved for a credit card. And then someone who has a poor payment history would come back with a high risk score and not approved, right? You might also have some confusion matrices or feature importance plots. The key is when you get to the end of this process, this is typically a big kind of milestone in what's going to happen next, right? So a lot of times that will be the end of it, and you'll sort of use the notebook for offline predictions or code it into a script and schedule it. But here we actually want to move it into Algorithmia's model catalog, so it can be a live algorithm that's actually serving requests on demand, right? So I'm going to do a couple of things here. First is to save the model. Again, I'm showing a specific format here, joblib, but we don't restrict what you can use. Pickle, you can use a TensorFlow directory, whatever output is coming out of your model. So we're saving a joblib file, and then we're uploading the model and this feature importance plot into Algorithmia. One thing to notice is I'm uploading this into Algorithmia's data collection. You could also be uploading this to S3 or Azure, Google Cloud Storage, any of those connectors I showed earlier. But the main point here is some training happened, we saved a model, and we saved it somewhere that Algorithmia can see it for the next step, right? So we're done with the notebook, and as you can see, there's flexible ways to kind of do everything in the notebook, even creating an algorithm and publishing it. But just for the sake of simplicity, I'll show those kind of explicitly here. So if we go back to our credit card model and look at that, let's look at the source code and see what's actually going on in this algorithm. So I'm going to zoom in here, and you'll see basically this 50-line Python script is basically doing a couple of things. So we're importing some things, and then we're loading the trained model. So in this case, we have a couple of different options. We have a gradient boosting classifier, random forest classifier. So we're loading a trained model from the earlier training step, and then we're processing the inputs, generating a prediction, and then returning that. So you'll notice a couple of things. Number one, this is all code. So this could be Python code, R code, Scala code, Java code, or a few others. And so what this means is we don't restrict, what format you're using. All we're doing is saying, give us a predictor function or a calling function, and then we'll use that to make your algorithm talk out to the world. So the other thing to note is that this apply function is where all the interesting things are happening. So every time your algorithm gets called, the inputs are going to go into this apply function. We're going to process whatever code you have in here, and then return a JSON response that has the predictions or whatever it may be. So that's what's going on, behind an algorithm. That's what's actually powering an algorithm. There's a few other things in here, like the dependencies list. If you need to list certain versions of dependencies like scikit-learn, TensorFlow, to match whatever you did in training, you can do that here. And then the most important step that happens is the build and publish. So if I click build, what's happening now is that Algorithmia is taking my serving function, my predictor function, it's taking all the dependencies that I gave it, it's containerizing all of that and getting it ready to serve once I've basically approved this model that it's working well. So this build step is doing all the containerization. You don't have to do any of that by hand. And really, all I've done is just say, here's my Python predictor function. Let's get it ready to publish. So once the build step completes in a few more seconds, there's going to be a message at the bottom. And then I can basically send a test query to say, here's an example query. What does that look like? Is the model behaving as I expect it to, right? So there's our console at the bottom, says we have a new development version. I can send it a test query. When I'm ready and happy with this, I can publish a new version. So I'll do that now. You can see here, there's test inputs and outputs. Great place to test to make sure things are working as I expect. And then this is where I'm actually going to publish a new version. So I'll bump this to version 15, publish, and that's it. So all I did was hit build and publish, but on the back end, Algorithmia created a Docker container from my latest version control of this predictor function, and basically gave that an immutable version, serving it in Kubernetes. All of that happened with build and publish. So again, we like to make it really easy to do that. But keep in mind, you can also add in different approvals and checks that if they need to happen. So that's why we always say we're moving towards production, not just jumping over with a one button push to production. So let's see, let me regroup and see where we're at here. So now that you've seen what makes up an algorithm and how you actually go from training to production, this is a good time to pause, take a breath, and see if you have any questions about, do we work with XYZ framework, or, what if I wasn't using a Jupyter notebook? Feel free to ask in the chat, and we'll address that in the Q&A. But hopefully you saw like the straightforward process of going from training to production. I showed you one way of doing that, but there are a lot of different options that you can do on top of Algorithmia. I could clone this repository and work in the Git repo in my favorite text editor. So basically, instead of clicking build and publish, I would just do a git commit and git push, and Algorithmia would do all of the same thing. So anyway, if you have any questions, about tools you're using or things you've run into in the past, please ask in the chat, and we'll get to it in the Q&A section. Okay, so let's take a look at the other side of this, right? So we looked at the data science side. Let's look at the consumption side and see how we'd actually call a model from outside of Algorithmia. So I'm going to jump over to a PHP web app that I'm running that is hooked up to actually call that credit card approval model, right? So let's just take a quick look at this app. Basically, if I visit this app, this might be internal or customer facing, whatever it may be. Whenever I click score application, maybe a customer fills in their information and clicks to apply for a credit card, and then ultimately get back an answer, right? Like you're approved for a credit card, you're not approved for a credit card. So this PHP app, let's jump over to the code real quick, and I'll show you how this works. Basically, what we did is to go to our credit card model, grab the PHP client and the code snippet. And you can see in the code snippet, we bring along the API key, we bring along the model, the version, all of that stuff. So you hand this over to a PHP developer. They're going to basically go in and make whatever changes they need to the PHP. So here, again, I won't go through this line by line, but just know that this is a PHP app. I've just pasted that code snippet here. So now this PHP function is calling out to Algorithmia with certain inputs, and then Algorithmia is running that algorithm, returning a response, and now I've essentially embedded that ML capability in my consuming application. So that's a kind of a simple example for a PHP web app. You might also have a case where you're running GPU models, you're doing batch jobs, however you're triggering these, right? Just know that those are all just ways to consume things from Algorithmia. All right, so hopefully that gets you thinking about different use cases you might have. Again, whether it's real time, whether it's streaming things, documents or images, or some kind of batch process that you're running. Okay, so now that you know how about consuming apps, let's talk about a few more things here. So let me jump back over to our slides just to give a high-level overview. Let's talk about pipelines for a moment. So in Algorithmia so far, we've just looked at very simple models that are, one algorithm equals one model, and we're calling that model directly and getting a response. There's a lot of powerful things you can do with pipelines. So a pipeline is just two or more algorithms that are chained together. And again, there's when you look at the code, it's very simple. It's a Python code calling two or more algorithms in succession and kind of handing off the result to the next. So let's take a quick look at how that might work, and some use cases we have in the real world where in this case it might be a media company, a customer that is looking at PR releases or press releases that are coming out and trying to do a sentiment score on them and identify negative news stories that are coming out, so they can pass that off to another team to address it. Basically, this pipeline takes in text files, identifies the language, translates it if it's non-English, vectorizes the text, and then performs a sentiment analysis on that and outputs the result. So the cool thing here is you might notice each one of these boxes is an algorithm. So this is 4 algorithms being represented here. Each box could be its own language, its own version. Some might run on GPUs, some on CPUs. So basically, what I'll show you really quickly is how to take a pipeline like this, how it works, and how to move to. So let's say we had version 1 that only reads in text files, and I discovered, hey, my coworker over in another department actually wrote an OCR model, and I want to add that into my pipeline. So I'll show you how that's a very quick swap and how you can actually move or increment on a pipeline like this. So let's jump over to that example. Here we are. So here we are. It's just another algorithm, but behind the scenes, it's actually a pipeline. So I'll show briefly the source code and show what this is doing. So basically, we send this an input, which is a directory, and then it scans the directory, grabs all the text files, and gives me back a sentiment score. So I can see this text file has about a 47% sentiment, between 0 and 1. So let's look at the source code and see what's going on. So I won't go line by line, but basically, anytime you see this this pipe call, right? This is a call to an algorithm. We're doing it in succession. So all of what you saw in that visual diagram is just lines of code here. And so we're calling the language identifier, we're calling the translator, we're calling the sentence detection, one after the other, and passing things to this pipeline. So Algorithmia will actually detect that this is a pipeline. It'll preload and pre-warm all of these containers and try to keep our pipeline as performant as possible. So what I'm going to do here real quick is just comment out the text file reader, uncomment, and call out to an OCR model instead. And then when I build and publish, I'm basically going to have the next version of this pipeline. And then when I call it, it'll be able to read text files, PDF files, Word documents, more things than just text. So very quick example, but I just wanted to show the power of pipelines, right? So we'll say support for documents, and we'll continue there. We'll publish version 2. And now when I go back to the algorithm landing page and run this, I should get back results for a text file and for a PDF file. So just like that, I took my pipeline, I added a module or an algorithm to that pipeline, bumped the version, and now I have a new pipeline that can do more things. And all I had to do was just grab an algorithm that someone else already wrote, right? So there we are. We have a PDF file, text file in version 2. Great. Okay, good deal. And so let's talk next about a couple of things. We'll talk quickly about usage reports, cluster metrics, and compliance auditing, and then we'll end off with model performance monitoring. So we'll just give a small taste of these. Again, these very deep topics, so if you have any questions about how this applies to your own use case or work, please let us know. So first thing is, let's just look as a cluster administrator and say, hey, I'm interested in knowing what's all the activity across my cluster. And I might want to know that for chargeback or showback purposes to say which departments or which projects are using the most compute. I might want to know which models are getting the most traffic. So we have usage reports that are really easy to view here or export to a spreadsheet. I can basically go here and sort by algorithms or sort by users and get a really quick view of, these are the algorithms that are getting called, whether they're CPU or GPU, and I can very easily kind of see that level of usage. Another thing that I can look at are kind of a unified logging system. So this is great for things like compliance audits. So I can go into this logging system and I can look at all of the API calls that are happening across the cluster, right? So I can see here and I can filter if I have a certain timestamp I need to investigate. So there's a couple ways to use this. You can go back and say, there's a query that happened 9 months ago and a prediction. I need to see who called it, what data was used, and when they called it, right? So I could drill down to one particular case and figure out what was called across any API call across our entire catalog. Or I could use this to get a high-level view of what types of model calls are being made, what consuming apps are doing that. So because we're logging all of that, you have an audit trail to be able to do things like that very easily. The last piece I wanted to show is about monitoring and alerting. So again, all of the things I'm showing here, we ship as part of the Algorithmia stack. So out of the box, we measure 90 different KPIs to really tell, is the cluster healthy? What's the latency on the models? What's the back pressure on the queue? What's the CPU, GPU utilization? So all of this stuff is being tracked and monitored, and you can forward this along to any other operational monitoring systems if you need. So the last thing I wanted to talk about in our list here is model performance metrics. So what we just looked at was more about the cluster health and operation. Are the models running? More recently, a lot of our users are asking the question, are the models right? It may be running, it may be fast, but I need to know if there's concept drift or data drift occurring, and I need to know that sooner than our semi-annual review, right? Every 6 months, I need to know that real time. So in our last release earlier this year, last year, we released something called Insights. And what it does is it basically is a flexible integration solution for being able to monitor performance metrics and send them to systems like Datadog, Kibana, Grafana that do really well at alerting and anomaly detection and things like that. And so really, this is a way to identify and correct things like model drift, data skews, negative feedback loops as they're happening, and be able to mitigate this and reduce your risk. The way this works is that for each algorithm, you can think of Insights as a global metrics pipeline. For each algorithm, you can instrument the metrics that you care about. So if it's an image classification model, you might want to instrument the confidence score. If it's a regression model, you might want to instrument the input and output distribution. Whatever that is in your algorithm, you basically tap into custom metrics that you care about. Algorithmia will take that and send that payload to Kafka, which you can then integrate with hundreds of different things, some of them shown here. We have out-of-the-box connectors for Datadog, for InfluxDB, but it's fairly easy to connect this up with Kafka to many other types of systems. And what this means is that you can take something like maybe you're monitoring a risk score and set that up in something like Datadog with an anomaly detector. And if this alert is triggered, you can notify someone and they can go in and take a look and see if there's something wrong with the model, if it needs to be updated or retrained or extended. Or you can use this to trigger a system, and maybe that system can do continuous retraining. So there's a number of ways to do this and set these up, but the goal is monitoring and alerting on performance metrics that you care about in order to close the loop on these are the models in production and this is what I did back in training. So we want to tighten that loop and avoid the manual time-based retraining and move to a more data-based retraining approach, right? An ongoing approach. Perfect. So with that, I'll walk into the summary here and then we'll open it up for questions at the end here. So just to wrap up, we looked at a lot of different things. First we looked at some concepts and then we looked at some workflows that were really around how do I go from training to production? How do I do versioning? How do I do pipelining? All the things you might need to do as part of your serving workflow. So to summarize all of that, if you look across what Algorithmia is doing for this part of the ML lifecycle, it's basically taking any kind of training integration or framework that you're using and layering on deployment, operations, governance, and security. So what that means is everything you see here in terms of the model catalog, data connectors, languages, we handle all of that in terms of at the model deployment part of what we do. The operations is mostly about monitoring and alerting, scaling up and down, and basically abstracting away all of the infrastructure that powers a model catalog like this. And then finally, governance and security lets us do all of these things, no matter the language, no matter the framework, all in one place, right? So it's all about centralizing your ML models and then operating, governing, and scaling them from there. So the biggest benefits we see, for our users that are kind of centralizing on Algorithmia as an ML deployment and operations platform is 4 things: time to value, being able to deploy models faster because you don't have to create a new deployment pipeline for every single different model. Optimizing productivity by letting data scientists focus on their tasks and DevOps and MLOps focus on their own tasks without having to bleed over different responsibilities. Managing infrastructure, so that can be very manual, and you really don't want to have to scale your ops team as you deploy more models. You want something that's very reusable. Finally, protecting your business, so being able to minimize risk by having a model catalog that's secure, governed, has audit trails, and ultimately has that real-time monitoring that we talked about in the end. So with that, hope you found this workshop useful. Again, feel free to go and try out some of the things we showed today. There's a few links here for you to be able to follow up on these. The first one is our ML infrastructure guide. So you can go there. It's a 5-series guide that digs very deep into some of the topics we talked about today. You can try the deployment process yourself. You can go to our development center. That's the second link there. That basically will let you, do everything we did today, right? So if you want to deploy your own scikit-learn model or TensorFlow model, go there, sign up for our Teams account, and try it out yourself. And then finally, we have kind of a showcase of use cases, so you can log in and try out, some image classifier, language processors, just to get a feel for some of the use cases that our users are doing today. So with that, I hope you found this workshop useful. I appreciate all of your participation. I look forward to your questions coming up here. And thank you so much for your time. So what we'll do now is transition over to the Q&A. And we're very happy to take any questions you have about any of the topics we discussed here today. So thanks so much.
All righty, Christopher, great presentation.
Hello, thanks a lot. Appreciate the time and the opportunity.
Active in the chat, getting a lot of questions answered. But if anyone has additional questions, please feel free to get them in.
Yeah, absolutely. I saw a couple that I didn't get to that I'm happy to address now, Sam, if that makes sense.
Yeah, absolutely.
Yeah, great. There was a question coming in at the end, especially we were talking about pipelines. So I will repeat the question in from Thomas. How are the individual components of pipelines versioned? Is there a way to always use the latest version? So the answer to all of that is yes. Whenever you have what we call an orchestrator algorithm, this basically lets you pin to specific versions and say, my pipeline has 3 stages. That could be Java, R, Python, and I'm going to lock into these specific versions. So all of that pipeline would be versioned and guaranteed to work. And Algorithmia is actually going to watch that pipeline and keep it warm as much as possible, so you don't have to wait for this cold start problem every time. You can also revert that and say, I actually just want to use the latest version. So you can kind of pick and choose, and you might have one pipeline that's pinned down really specifically, or another that's using latest. So totally up to you. And pipelines are a great way to break up your code in microservices and get all the benefits without having to manage every single networking component and things you usually have to do with pipelines. Looks like there was another question that came in about Prometheus for metrics. So it was a lot of information in a small amount of time about metrics and how we do. So the way you can think of it is we have a number of operational platform metrics that we record, things like GPU, CPU usage, how many slots are on a worker. This is how we know when to scale up replicas in a container, when to scale up CPU and GPU workers. This is all happening automatically in Algorithmia. A lot of that machinery that we use for that, for our scheduler, for our metrics and operational, so we measure 90 different KPIs, a lot of that uses Prometheus and Grafana, Kibana, Elasticsearch, all of this kind of systems you would expect, all in the Algorithmia box. The insights part that I was talking about in the later part of the presentation is more about inference metrics that you need to gather. So things like confidence scores, things that are beyond, is my model running? Things that are more answering the question, is my model right, given real world data? So things like data drift confidence, and that data flows through Kafka, and Kafka has hundreds of different connectors to end up in things like Datadog, InfluxDB, Grafana, New Relic, things like that. I think that I'm caught up on questions. There were some interesting questions that came up about GPU sharing. So the short version is yes, we do support GPU sharing. There were questions about being able to call Algorithmia in different ways. gRPC was one of them. So today you can call a model in Algorithmia through a REST API, like we showed, or you can also use things like event listeners to hook into Amazon SQS or Azure Service Bus queues. So lots of interesting use cases we see out there. And the impression you should get is that you can use Algorithmia for something like real-time scoring for individual calls, or batch scoring, or even batch jobs, right, where you're submitting something that's driving, hundreds or thousands of model calls to actually run. So all of that, hopefully you see the flexibility there of why we've designed Algorithmia to be flexible in this regard, right? Whether it's what language you're using, what frameworks you're using, all the way down to, is it real time or batch or both? Do you need a pipeline? So those are all decisions you can make on an algorithm by algorithm basis based on whatever you're trying to do in a particular use case. So with that, I think we're all caught up in questions, unless there's any others that I missed. So I'll pause there.
Last call for questions for Chris.
Yep, and I'll just grab that last one. It was really good. I'll just repeat that one really quick. There was a question about what happens if you don't bump the version? Do you clobber the current version? So if you didn't see that in the chat, that's actually one of the really big reasons that Algorithmia enforces certain things and doesn't enforce others. So versioning is one thing that gets enforced. So imagine you have a model catalog, you have hundreds of models, which is very much like our customers. And that's why we don't say push to production. We move things towards production. So every time you make a change, so say you have version 1, it's deployed, it's working fine. Anytime you make a change, we will ask if you want to bump that to version 2 or version 1.1 or version 1.0.1, your choice, but you do have to bump that. It means you're going to get a new immutable API version, and that version 1 is not going to break everything that you've tied into it in production. So it's a great way to think about A/B testing, canary deployment, shadow deployments, using some of those version specifiers. And the other nice thing is that you have all these versions, but they're only running when you ask them to. So you don't have hundreds or thousands of versions just sitting there idle, costing you cloud compute costs, but rather they're just running on demand, right? So that's happening all the way down to the specific version that's being asked for. So yeah, with that, thank you for the awesome questions and participation. I hope you try out Algorithmia, see where it fits into your pipeline. But with that, I'll hand it back to you, Sam.
Awesome. Thanks so much, Chris.
Yep.
Thanks, everyone, for joining us. And this concludes day 3 of TWiMLCon. I hope you had a wonderful day and learned a ton. Tomorrow morning, for those of you who are joining us for the Executive Summit, we'll get started bright and early, well, depending on where you are. If you're not registered for the Executive Summit and you are interested in participating in that, you can head over to the TWiML booth in the sponsor area and let us know, or visit or email registration@twimlcon.com. Otherwise, tomorrow, Friday, there is no scheduled content for the main part of the conference. So it is a great day to get on the platform and meet with people. Have a wonderful rest of the day, and see you tomorrow.